All right. Welcome to Pomodoro Joe for Saturday, January 28th, 2023. And today we're doing LeetCode problem 352, data stream as disjoint intervals. This is a hard problem. Given a data stream input of non-negative integers, a1, a2, etc., summarize the numbers seen so far as a list of disjoint intervals. Implement the summary ranges class. Summary ranges initializes the object with an empty stream. Void add num adds an integer value to the stream. And int get intervals returns a summary of the integers of the stream currently as a list of disjoint intervals with start and end being the two elements in each interval. All right. The answer should be sorted by start. Okay, and then they have an example here. So they're passing in 1, 3, 7, 2, and 6. And so when you have 1, you return 1, comma 1. All right, so you return start and end even if they're the same number. And then 3, so you have 1, 1, and 3, 3, because they are disconnected. But as soon as you add 2, so we have 1, 2, 3, 7, it returns 1, 3. Okay, this is pretty straightforward. Oh, we'll take a look at, this is even better. So taking a look at the constraints, we can see that our values are between 0 and 10 to the 4th, which is pretty small. So I have an idea of what we can do here. All right, with that, we will set 25 minutes on the Pomodoro timer and get started. Okay, so in our init, we are going to keep basically the stream. So one thing you can note here on the constraints, our values range from 0 to 10 to the 4th, and we have at most 3 times 10 to the 4th calls. I don't think we'll even need to bother with how many calls we get because we know our intervals are constrained, so we can have our stream. Actually, this will be self.stream because this is a class, so we want to keep track of this in the self. And that's going to be equal to, and we'll just initialize this with 0, and we'll make this times 10,001. So this basically will give us, so let me illustrate my overall plan. So the plan is to have some buffer where the index is the value you're inserting into the stream. So the index will just indicate, let me reiterate that again. We'll have a buffer where the index is the value that you're inserting into the stream. And the value at that index will indicate whether or not we have inserted that value into the stream. So we're going to start them at 0, and as soon as you insert this value into the stream, we'll flip it to a 1, and that's all you need to do. Okay, so I think that handles our init. Now in add num, again, this is super simple. We just say self at stream for this value. We'll just flip it to a 1. And there's no need to flip it back. We just have an add to stream. There's no way to remove things from the stream. And that's it. So now get intervals is the trickier part. Now we have to go through and build up our intervals. But I don't think that's actually that bad. So we'll have some result, and that's going to equal, well, some array of arrays or some list of lists. And we will have a, let's see, a current interval. And we'll set that to a list. And now we just need to go through our stream. So for index and value in our enumerated stream, so we'll enumerate our stream. This returns both the index and the value. If the value is equal to 0, we don't have this number yet. So let's see, for now I'm just going to pass. At some point, we might need to do something here. If the value is 1, that means we've got this number. So if we don't have a current interval, so let's see, if the current interval, actually, maybe I shouldn't initialize it here. I can say it's none. Yeah, I'll do that. So if we don't have a current interval, then we'll create one. I need to indent that. What are we going to put in our current interval? Well, we'll put in our value. Actually, no, we'll put in our index. The index is the value of the number in the stream. So we'll put our index, and we'll put another index as the end, just in case this is a one-element interval. Okay, that covers that. Otherwise, if we do have an interval and our value is 1, then we'll replace our ending value with our new value. So the current interval will still have index. No, we don't want to change the beginning, so we're just going to change the ending. So if we don't have an interval yet, we will create one saying it starts at this index, and we don't know where it ends yet, so we're just going to say it might also end at this index. If we have an interval and we have another value, or if the next value in our stream exists, then we'll just replace our ending with that index. Okay, and then at some point we'll run into the end of our interval, so this is where we come back to our 0. If we do have a 0, if our current interval, so if we have a current interval, then we need to close this one out, so we'll add it to the result. So we'll add our current interval to our result, and then we'll set our current interval to none, and then we'll continue. Actually, if we have, we could just do it continue out here actually, and then we don't have to do this check down here. Well, that's an optimization we can come back to. Okay, and then we do need to return our result, otherwise nothing's going to happen. I think that covers it. Yeah, I think that might be it. Let's give it a shot, see what happens. All right, I have something. Stream is not defined because it is self.stream. Okay, try that again. None type object is not scriptable. Oh, I must have, yes. I'm creating a new current interval. That's what that should be. And that passes. Let's see if we can pass all the tests. This might be too slow. No, we pass. All right, let's see how well we do. Not so great. We only beat 5.2% for runtime. We beat 43% for memory. That's not too bad. Let's go back. Let's see if we can make some improvements on our algorithm here. So one thing that we can note is that most of the work is being done in get intervals. You can just see that by the length of the code here. What if we could reduce this work? One way we can reduce this work is actually by caching the result. So every time we call get intervals, we're calculating all of our intervals from scratch. What if we didn't have to do that? So let's have some result cache. So we'll have a result cache. And we'll set it to none to begin with because we don't have anything. Then down here, we can just say, if we have a result cache, so we have to say if it's not none because it could be an empty list. So if we have a result cache, then we'll just return that result cache. That could significantly improve things. We'll skip all this other work. And if we don't have the result cache, well then down here, when we get our result, we will have to set it. Okay, now there's one piece that we're missing here. We need to invalidate our cache. Anytime we add a new number, we might need to invalidate the cache. So the first thing we do is we just check, is this a new number? If it's not a new number, then our cache is completely safe. Nothing changes. So we'll basically have to say, let's just do this. If self-streamed value is equal to 1 already, then we just return. We don't need to do anything. Else, we need to, let's see, basically set this back to 1, and we need to invalidate the cache by saying self.resultCache equals none. All right, I think that's it. Now we're caching our results every time we call getInterval, and we're invalidating it anytime we have a new number added to our stream. Let's see if this gives us any type of gains in our runtime. Small gains. So we go from that was a 5%, now we're at 14%. So we do make some small gain. Not great, but not too bad. What else can we do? Well, let's go back to this get intervals. What if we don't have to calculate this every single time? What if we kept track of the intervals as we go? Well, that gets a little bit trickier, but we can do it. So here's the thought I had. Anytime you add a new number, there's sort of a finite set of possibilities. Either that number is completely isolated, so it's a standalone interval by itself, or the number has some interval to its left, immediately to its left, or immediately to its right, or both left and right. If it has numbers immediately below it, then this number becomes the end of that existing interval. If it has a number immediately above it, then this number becomes the beginning of that existing interval. If this number is sandwiched between two existing numbers, then it bridges two intervals and we have to merge those intervals together. Okay, so it's a lot to keep track of, but I think we can do it. All right, let's do this. So we're going to have two mappings. So we're going to have a start to end mapping. And that's going to be a dictionary. And we're going to have an end to start mapping. Also a dictionary. So what this will do is this will take the starting index and it will map it to the end index of the current interval, or that interval that starts at that starting index. Okay, so now when we add numbers, things get a little bit trickier. Again, we don't need to do anything. We've already seen this number. We're totally fine. Otherwise, we do need to, let's see, we still need to do this, but the next piece. All right, so I had to speed this one up. It took a little bit of time to write all the code. You can check out the end result in my GitHub. I'll leave links in the description below. This code essentially takes a mapping of the start of an interval to its end and the end of the interval to its start. Anytime you have a new number introduced into your stream, then you either add to the end of an interval, start a new interval, add to the start of an interval, or merge two intervals that sit on either side of this number. So essentially that's what I'm building out here. These are the different conditions. Once those are done, then when you get to the end, or sorry, when the new request for an interval comes in, all you have to do is go through your sorted keys in your start to end mapping and return new intervals that are created from the start and its mapped end. Pretty straightforward. And you'll see in just a minute that the results are pretty incredible. All right, let's give this a shot. Cross our fingers and hope that it works. Whoa, check that out. This beats 99.35% of all the other algorithms for runtime, and it beats 43% for memory, which isn't bad considering we're using a lot of memory for these mappings. Holy smokes, I am super pleased with that. That is awesome. All right, thank you so much for watching. I hope you enjoyed this. I know I didn't describe this one as I was going. There's a lot of trial and error going on. So if you want, you can check out the links in the description. You can find this code on my GitHub and you can read through it yourself. Hope you enjoyed this. Hope you had fun. Hope you learned something. Please. Write better code.